Okay, so today in this video we are going to talk about the following concepts. We talk about correlation, regression, simple linear regression, multiple regression. How do we analyze regression? So we're going to talk about the models and the statistics and understanding these regression. And finally, we are going to learn how to interpret regression in Tableau. So first thing that we will talk about is understanding correlation and how it is different from regression. The word correlation comes from the word relation, and you can see the co, that means relation together. So basically this term means the degree of association between two measures or two values. If we plot two values in two axes, y and x, how closely these variables, not the values, variables are related to each other. So here you have, let's say, in one axis a plot of something, another axis another, and you plot a line. You will see that the degree of association is determined or shown in this line. So here we have a perfect correlation because all the points follow in one single line. It is positive because as you increase x, the y increases at the same time. This is an example of a perfect negative correlation because all the points are in one single line and the slope is minus, which is as x increases, y decreases. So we need to understand that correlation are basically it's a value. The maximum value that you can have is 1. So it means that if two variables have a correlation of 1, then they are perfectly correlated. On the other hand, if it is 0, that means there is no correlation at all. So the number will fluctuate between 1 and -1, and you will have somewhere anywhere between that range. To better understand the concept of correlation, we will look at it with some examples here. Let's see these examples as we saw here, y and x. So this is perfect positive correlation because everything is on the same line. There are no points scattered around this line. So, but there are some scattered points around this line, so this is not a perfect correlation. So if this is 1, then definitely it is less than 1. But there is some correlation because we can see there is a trend. Here the correlation is almost 0 because we cannot draw a line with so many points which is scattered around. Similarly, this is a negative correlation. It's not perfect because it's not in a line, but there is some correlation, and it is -1 because it's everything in a single line. So we have understood the value of correlation. One thing we need to focus here, that correlation analysis is not much useful. It is useful to know how two variables are related, but the value of it in the business world is not much, because if I say that sales and profit are related or correlated, or shipping price and sales are related, the next question that would pop in my mind is, so what? So what if they're related? So we don't really do the correlation analysis in analytics. Rather, we focus on another important term, which is called regression. So now we are going to focus on regression, and regression is much more than just how two variables are related. So regression focuses more on to understand the relationship between two measures or variables, and the key word here is the dependence. That is, how much one variable is dependent on other. If you're able to find that in a lot of measures in business, then it makes a lot of sense. If we know that profit depends on sales, if we know that shipping price depends on sales, that means if we do some adjustment in sales, then definitely that will be reflected in profit or shipping price. That's why regression is much more powerful than correlation. In correlation, we cannot, if we say that, okay, profit and sales are highly correlated, we would not be able to determine that whether profit is explained by sales. So before we go to regression analysis, we would like to consider two terms. One is the concept of independent and dependent variable. So if we plot a graph, we have two axes, and let's look at a graph. We'll come back to that graph later, but let's look at this graph quickly here. What you see here is y-axis and x-axis. So whatever we put on x-axis is independent variable, and whatever we put on y is dependent variable. And the way we interpret is y is dependent on x. So y is something that depends on x. So if you put sales as independent variable, then I can say that shipping price depends on sales, or profit depends on sales. So therefore you can clearly understand that what measure we use in which axis depends means a lot. So if you put sales here, we should put profit or shipping price on the y-axis. We should not do the reverse. That means we should not put sales here and shipping price here, which would mean that sales is dependent on shipping price. That is clearly not true. So this kind of business decisions has to be made in advance to find out what kind of relationship hold in these variables, and whether they can explain the effect of one on the other. We can use the word effect, we can use the word depend, but this is, as you see, it is much stronger than the concept of correlation. So after we have understood the concept of regression, especially the independent and dependent variable, we have to understand that in generally this line is represented by an equation, and often this line is called trend line, which we will see in Tableau. Typically the equation would be something like this: y equal to c plus bx plus e, and we need to understand the meaning of these, and then we will go into details about how to interpret the equation. So let's go back and check the concept of regression line. So before that, we talk about the dependent and independent variable. We just said dependent is independent, and we need to understand how these two variables can be linked in terms of prediction. So this is what the equation that looks like: y equal to beta 0 plus beta 1 x plus error. We can replace beta 0 by c or something else, and let's understand the meaning of this. So basically this is an equation of a line from here to here. We'll talk about the meaning of error very soon. So y equal to beta 0 plus beta 1 x, and what does it mean? So what it means here, that beta 0 is called the intercept, y-intercept, which means that if the mean of y, it's the mean of y when x is 0. So if I put x in 0 here, then the beta 1 into 0 is 0. So ignore the term error. So basically y equal to beta 0, and that's the y-intercept. Beta 1 is the slope of the line, and what error means that y is dependent on this. But it may not be true that y is 100% dependent on x. There could be some part that y is not able to explain. So that is the error, and we will look into it a little bit more later when we talk of multiple regression. So let's understand the concept of multiple regression, the concept of this line. So here we are talking about the linear regression or the multiple regression. So this is the slope. The equation of the line is still here: y equal to beta 0 plus beta 1 x. Beta 0 is the y-intercept. So basically it is distance from here all the way to here. So if I draw a line that intersect the y-axis to a certain point, the distance from the 0 is called the beta 0. So this is a constant value. This value is pretty much constant. So here is a simple linear regression. So we need to understand the two terms, simple and linear. Linear means the line is straight. Now it's not necessary the line will be straight all the time. The line could be curved, or it could be different kinds of curves. But here we assume that the line is linear. It goes back to the concept of normal curve. If we assume the data is normalized, then we can also assume the data will be linear. If it is not normalized, then we have to assume some kind of regression model, a different regression model, which will look different. So simple means there is only one independent variable, which is x here, and y is the dependent variable. If we have more than one independent variable, such as x1, x2, x3, it will be multiple regression. Okay, so we know that this is an equation of a line, this is an intercept. So basically, if I'm able to find out beta 0 and beta 1, then I would be able to understand the relationship between y and x pretty clearly. For example, if I take the example of profit and sales, so profit equal to beta 0 plus beta 1 sales. So if I can identify the value of beta 0 and beta 1, then I would be able to identify exactly how much dependent this profit is on sales. So let's understand one more thing, which is the coefficient of determination. So the next question that comes is how useful this regression model. If it is useful or not, we look into several things, and one of the most important thing that we look at is called R-square. And we will look at the table and see the value of it. If R-square is high, that means the model is pretty useful for our purpose of understanding. If R-square is close to 0.7 or 0.8, that means 80% of the model is being explained by that one independent variable. Okay, so we will now let's look at very quickly multiple regression, because this is much more powerful and it works in more complex situation. Now, in the complex business world, it can never happen that one independent variable can explain everything. For example, one independent variable is sales, and that explains the dependent variable profit. That is certainly not true, because profit might depend on something else, and some of the variables we might never be able to understand, and that's why you use the term error. So when we have this situation, and there is no limit of the number of independent variables that we can put here, so that's the time we use the multiple regression. But remember, multiple regression will always have one dependent variable. So there will be just one y, but there can be, or there will be at least two x. So if we look at the equation, it will be looking something like this, where x represents the number of independent variables. It could be x1, x2, x3, as many as possible. There will be only one beta 0, which is the y-intercept. So in other words, we can say that profit is dependent on sales plus something else, promotion, and something, all other factors and variables. So it can explain everything, but you know, there could be some factor that is not explained by the combination of all these independent variables, and that unknown we call it as error. So let's understand one more thing, and then we'll go back to the so this is the model that we are talking about. And what happens is we generally look into R-square, the value of R-square, to understand how important or how important if this equation is. You know, high R-square means, okay, we have to look at this equation pretty seriously. If it is low R-square, means, okay, that relationship is good but not that strong, and maybe we should not lie our business decision based on a very low R-square value. There is also a concept of adjusted R-square, and the concept means that if we add any variable to an equation, no matter what variable we add, the R-square value will always increase. This is just because of the mathematical nature of R-square, even if the variable that we include has no relations to y. In other words, suppose we have y equal to beta 0 plus beta 1. Suppose we have this beta 1 plus beta 2 plus x2. If we add x3, even though x3 is not related to y, still the value of R-square will go high. So there is a mechanism to control that, and that is what is called adjusted R-square. So in other words, adjusted R-square is much more accurate reflection about the strength of the relationship. Now let's quickly go back and look at what are the things that we see in a regression model, and then we go back to Tableau to see how do we understand regression in trend lines. So first is we understand regression by looking at the coefficient, the model, the overall model, and also we look at R square and adjusted R square. So as you can see, this is a multiple regression because it has intercept and it has two variables. So there are two x. So in other words, if I am able to write the equation of this line, it will be y equal to intercept plus population, the coefficient of the population multiplied by x1 plus coefficient of the bus ratio multiplied by x2 plus error. That will be the complete line equation of the line. In other words, it will be y equal to 125.289 plus x into 14.1996 multiplied by x plus 22.8107 multiplied by bus ratio plus error. Now because there are two independent variables here, so that's why we use that's why we know that this is a multiple regression. In Tableau, you will be able to see only one intercept and one variable. You will never see the third line, because if there is a third line, then we are talking about multiple regression. So when we are presented with this kind of statistics, first thing that we look is this equation that I just said, whether that equation is significant or not. We look at the value or the significance of this, which is called p-value. Here it is, p is less than 0.05. So we first look at this value, which means that out of 100 times, 95% of the time the equation will be working. So maybe in the 5% of the time the equation will not work statistically. So first thing that we look, before we look at the coefficient, before we look at the R square, we look at this value. If the value is less than 0.05, that means, okay, the model is significant, the equation is significant. Now let's look at the model itself, and the way I explained you the y and relation to y and x, we will use the coefficient to draw the equation. Next thing we will look at is the value of R square. In particular, we look at adjusted R square. Here, the adjusted R square is very high, 98 or 97. Adjusted R square will be slightly lower than R square. In Tableau, we are going to get only R square. So what does it mean? R square is 0.98. That means 98% of the model is explained by these two variables together. So that is an extremely high R square, and typically we will not find that kind of high R square in our models. Okay, so now we will create a simple trend line in Tableau, and we will try to understand the terms and statistics behind that line. Okay, so now let's continue to create a small trend line in Tableau and try to understand the statistics part of it. So what we'll go is we'll create a sample superstore data in Excel, and we will create a quick a scatter plot using this data. So we will connect the data, and we will use the Excel file, the worksheets, and quickly create the trend line. Okay, so in order to create a scatter plot, because scatter plot works only with measures, which are the numbers, numerics, so we have to use two measures. So what we are going to do is we are going to take sales in column, and we will take profit in row. Okay, so you will see that automatically this is highlighted. That means this data set is well represented, or we can represent this data set with trend line. Okay, let's minimize this. So as I said, we have to be careful on what we put in the x-axis and y-axis. So our independent variable is sales and dependent variable is profit. So profit is explained by sales. Now, because we are using just one aggregated data, some sales and some profit, so we are going to only have one data point. So you'll see the total sales and the total profit. So we are now going to plot a line just using just one point. So we need more data points, and what we will do quickly is two, three steps. First is in color, we will put a region. So customer, and we have region here. We'll put in color. So by doing that, now we have 4 regions, and we are going to increase the data points from 1 to 4. Didn't drive it. Yeah. Okay. So now we have 4, and then we have the overall sales that we have. Um, no, sorry, we have 5. 1, 2, 3, 4, 5. Okay. Now, this is fine, but this is still not enough because there is not enough points. So let's add one more thing here. We will add the in our shape. We are going to add product category. So this is product category. We're going to add in shape, and we see quite a few points, but regression analysis is way better if you have much more point, and that's why we will add customer name and drag it to detail. Once we do that, we have significant amount of data here, and the reason being we are analyzing each and every data point in this case. So we have this different areas, and because of so many data points, it is better to analyze using the scatter plot. That means for all these customers, does the relationship hold, which is profit, can be explained by sales. So we right click and create trend lines, say show trend lines, and based on 5 points, 1, 2, 3, 4, 5, you're going to have 5 lines. Now, if you just hover our mouse right here, we see that the equation of the line is shown here. Profit equal to 0.025 star sales plus 38. That means 38 is our y-intercept, sales is our independent variable, and profit is the dependent variable, and the p-value is 0.02. So you can see clearly this is a simple regression analysis with only one independent variable. And it is significant because the p-value is 0.02. We are going to look at it in a moment in a little bit more details. This is a better p-value, so this line is much more significant, strongly significant. Same with this line, and same with this line. So let's understand the equation a little bit in more detail. So we click on one particular line, and we will do two things. We'll first describe the trend line and then describe the trend model. Let's click on the describe trend line, and we see that the p-value for the overall equation here, so we have two sets of p-values for the equation, p-values for the coefficient. P-values for the overall equation is 0.0001, and which is the equation is profit is this times sales plus 469.0919. So we see that this value here, this is, if you recall, this would be the intercept, y-intercept. This value is the slope, and this is the independent variable. So for this equation, it is valid, and therefore, once we know that the overall equation is valid, we look into the independent coefficient. Now, if you see the coefficient, we don't look at the coefficient of the intercept, so we don't look at these values. We look at only 3 points in this here: sales, the coefficient value, the intercept value here, and the p-value of the sales. So from this 0.35 is actually the slope of the line. Intercept minus 469 is minus 469, that is the y-intercept, and we look into the p-value of the sales. So first we look at the overall p-value, and we saw that this is significant. That is fine. That means we are now able to explore the relationship between sales and profit. The second thing that we do is look at the sales p-value. If the sales p-value is higher than 0.05, that means though this line is significant in terms of a trend line, but the equation between profit and sales is not correct in terms of sales. Profit cannot be explained by a certain percentage of sales. But because the sales is p-value is less than 0.0001 or less than 0.05, so that means this is sales. The relationship holds. That means profit is explained by sales. So we know this description in brief. Now we'll go and look into the model in a little bit more details. So we click on the trend model, and this is similar to what I showed in the earlier part of the video. We will see that this is the overall p-value. We already checked that, and what it shows here is these are 5, 1, 2, 3, 4, 5. These are the equations for the 5 different lines. So it is not one single equation, it's 5 equations. So it's individual trend lines. So for West region, this is the line. So where we have p-value as profit. We will look at the p-value here. It is significant. For sales, it is not significant. That means the equation doesn't hold well and significant, because the p-value for the sales is 0.02, which is more than which is, yeah, no, this is still significant because less than 0.05. But it is really not strong. We don't look at the intercept value, but it seems to me that all of these have the sales are significant. Okay, one more thing, as I said before, we look into the R square value. The R square is 0.49. That means, yes, the number is pretty high, 0.49. That means almost 50% of the model can be explained or attributed. That means the profit explain this relationship hold is pretty strong. 50% of the profit is explained. Then you might ask that what about the rest? Now remember we talked about the E, which is the error. That means E explains, that means there are other factors that will explain 51% of the relationship. So still in the business world, 49% R square is pretty high R square. So we can go ahead and make some business decision based on the information that we just found. If the R square value would have been pretty low, like 0.2 or 0.05 or anything less than 0.2, then it's not a good decision to base our decision based on this model. So we look into R square value, we look into the overall p value, we look into the p value for the profit, and we also look at the p value here. So we check all these values to interpret the regression equation. So let's summarize what we focused in this video. First, we talked about correlation. We clearly know that correlation is much less powerful than regression because correlation just talks about association between two variables. It doesn't talk about whether one variable can explain another variable. Now, explaining another variable is very important in business. That's why we use regression in analytics and we don't use correlation. We can definitely find the correlation values, which is the R, which range from -1 to 1 by using any statistical package, or even Excel you can find out the correlation value of two variables in Excel. So we know the difference in correlation and regression. We know what is simple linear regression. Linear means the line is straight line. Simple means we are using only one independent variable, which is A, which is X. That means our line equation for a simple linear regression is y equal to beta 0 plus beta 1 x plus error. And when we talk about multiple regression, we are going to still use only one y, but the equation will read as y equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x3, and so on, and we'll add on error. We always add error because our equation is, that is how y explains x, it cannot be done 100%. So that means there will be some variables that we are not going to be able to identify, and that's why we leave some part of it in terms of explanation. Then we talked about analysis of regression, how to interpret the statistics part. We know that there are several things that we need to understand in both in terms of in the tabular format and in the regression and statistical format. The output of these are very similar. If you take an output of SPSS or any statistical package, the trend model that is just showed in Tableau would look very similar. So first thing that we do in step number 1 is we look at the overall model, whether that is significant or not. That value has to be less than 0.05. Sometimes you will see statistics value, sometimes you will see p value, but basically it means that the model has to be significant, that the equation of the line has to be significant. Moreover, in Tableau, you will be able to see only simple regression. You cannot do multiple regression in Tableau. That means you will not be able to explore y equal to beta 0 x plus beta plus a1 x1 x2 and like that. So we'll just have only x. That means in y we will be able to have only one variable at a time. And after we see that, after step 1, which we see the overall p value, then we look into the slope of the line and see what is the p value for that x. So if the value is less than 0.05, then it is good, and we are able to use that equation. And finally, we look at the R square value. The R square value is high. That means this equation is very good in terms of application, and we can use the value for our analysis purpose.